Did you know that GitHub in September 2012 faced a major performance issue all because of a minor database issue? Imagine you are booking a Tatkal ticket and suddenly IRCTC goes down. What will you do? Put yourself in the shoes of an architect of one such application. How will you choose the right database? Today, I'm going to help you evaluate 6 key criteria based on which you can choose the right AWS relational database for any of your application. So we will look at 5 practical scenarios and compare with these 6 key criteria and choose the right database for our application. Let's get started. The first one, let's assume you are building an attendance system for your office or your college. We'll start simple, but the next example is the IRCTC one. So stay tuned. First one, we are building an attendance system. We will look at 6 key criteria. Criteria number 1 is what is the type of workload? Is it a transaction system or an analytical system? The attendance system is obviously an transaction system. People are going to apply leaves, cancel leaves, modify their leaves, and stuff like that. What are the latency requirements? This application is not super critical, so it need not be super fast. We don't have very high latency requirements. Does it need rapid scaling? No. You are not going to have suddenly 1,000 people applying for leaves, so it doesn't need rapid scaling. It's predictable load, predictable scaling, so no fast. Fourth one, is this going to handle huge amount of data? No. Again, you are not going to have millions of employees applying leaves and changing every day, so the amount of data handled is very less. Do you need extremely fast failover in case of a failure? No. Again, like let's say your application is down for 5 minutes or 2 minutes, people are not able to apply leaves, they will be happy about it. So there is no need for extremely fast failovers in case of a disaster or a regional failure. The last one, the user load. Are there going to be too many parallel users? No, I can say medium level of users who might be using this application. So these are the 6 key criteria. Now, for this application, what is the database which you will choose? The recommended one is AWS RDS. Let's see why. First one, based on the workload, for transactional system, RDS is a really good database. Now, the moment you see transactional system, you should inch towards choosing AWS RDS. Now, there are other factors which you will consider as well. Here, the other factors are not much important. You don't have very high latency needs, you don't have high scaling needs, neither you need quick failover. So RDS using PostgreSQL or MySQL should pretty much work. Now it is time for us to look into the IRCTC use case. I need not give explanation on what IRCTC does. You all know that. Again, as a workload, it's a transactional system. People are applying for tickets, they are cancelling it, they are booking a lot of transactions and stuff. Latency, it needs to be super fast. Critical requirement. We don't want IRCTC to be slow at any point of time. Does it need rapid scaling? Yes. Whenever ticket opens up for some festival or Tatkal booking or something, suddenly there is a huge surge in the number of users. So we want to be able to support rapid scaling. The amount of data we are processing, it is literally huge. There are crores of people making transactions every day, possibly every hour. So the huge amount of data is going to be processed. Do you need quick failover? Yes. Think you are booking a Tatkal ticket, there is a disaster in some region, IRCTC goes blank. You will not accept that, right? So in case of a disaster, in case of an issue, we need extremely fast failover, possibly in just few seconds. It is that critical. User load, it's too high. You will have thousands, lakhs, or crores of users parallelly using the application. So your database should be able to handle such kind of a traffic. Now let's decide what is the database you will use. What is the type of system? Transactional or analytical? The moment it's transactional, it's RDS. Now you will be thinking, hey, it's RDS now, it's RDS for the previous use case. Why to have 5 other criteria? Here comes the tricky picture. Here if you see, you have extremely fast latency needs, you want extremely fast scaling, you want extremely quick failover. In this scenario, you will choose something called RDS Aurora. Aurora is a specific service from AWS. It's their proprietary technology. It's built on top of RDS. It supports PostgreSQL libraries, but this is super fast. It can handle extremely low latency. It can scale up to multiple reader and writer nodes in very short amount of time. It is really well suited for handling a lot of data, and it can do automatic failover in just few seconds. It can failover if an availability zone goes down in few seconds. If a complete region goes down, it can still failover in possibly less than 5 seconds. It is as fast as that, and it is also well tuned to handle crores of users parallelly making a lot of transactions. So if it's a transaction system, and if you need whether a extremely quick failover, or if you need extremely fast scaling, or you want extremely low latency under heavy load, you might want to consider RDS Aurora. Now let's quickly go on to the third application. Let's assume you are working for an airline customer who is doing their flight planning. They are going to look at past 6 months or 1 year worth of data, understand what was the load on each of their flights, and then they are going to prepare the plan for the future flights. Now what kind of a workload it is? This is not transactional. This is analytical. They are going to read a lot of data and do analysis. They are going to fire different type of read queries on top of the data. So it's an analytical system. High latency needs? No, because it's analysis, it can wait, it can be slow, not a major deal. Do you need extremely rapid scaling? I would say medium, because you are processing huge amount of data. Suddenly you might need little higher computational power, but it is not as critical as IRCTC or something. Do you process huge amount of data? Yes, huge. We might be processing 6 months or 1 year or 2 year worth of data in a single shot. Do you need extremely quick failover? No, because again it's an analytical system, it's not user facing, so it can handle downtime, so not a major deal. User load? No, you are not going to have hundreds of users firing analytical queries. You will possibly have few tens or few users running these analytical queries. So there is not going to be huge amount of concurrent user load. So which database will you choose in this? The first primary criteria is a type of workload again. It's an analytical system. So the moment you see analytical system, it is better to inch towards Redshift. But you also need to see whether the analysis is being done on very limited amount of data or huge amount of data. Here if you see, the analysis is being done on huge amount of data. There is going to be a lot of complex queries which are being fired. So in these scenarios where you want to do analysis, you want to process huge amount of data, you want to run complex queries and do analysis, AWS Redshift becomes the perfect fit for you. But keep in mind, Redshift is good at these things, but it cannot handle quick failover. In case of a disaster, Redshift will take its own sweet time to come back up. It cannot handle extremely fast scaling in very limited amount of time. It is going to take few seconds to do scaling. It cannot handle too many users parallelly. So consider these factors before you decide on the database. But for this use case, it is AWS Redshift. Now let us quickly move on to the next use case what we have. Here we have Flipkart's Big Billion Day. You all know about this. So what happens in Flipkart Big Billion Day? There are so many users, crores of users making purchases every second. Also, Flipkart is parallelly analyzing the user data, user purchase pattern, comparing it with the past 3 months or 6 months worth of data and deciding what offers you should see the next hour or what offers you should see the next day. There are two things happening. People are making crores of transactions every hour, and behind scenes, the analysts are parallelly analyzing all of this data, comparing it with the past data and taking decisions for the next hour or the next day. So what kind of a workload this is? This is transactional as well as analytical. Now comes the problem because it is both. How will you choose the right database? But let us look at the other factors and then come to the conclusion. Latency needs. It has to be extremely fast because it is a transaction system. People are making purchases. The latency needs are extremely high. Rapid scaling. Do you need to search or scale your resources really fast? Yes, because there are offer reveals, there are new products coming into sale and stuff. At the point of time, a lot of customers are trying to purchase things. So you might need extremely fast upscaling as well as downscaling. Are you processing huge amount of data? Yes, because my analytics team is going to analyze my latest data and compare it with last 3 months or 6 months. So they are making it really huge. So too much data is being analyzed and processed. Do you need quick failover? Yes, obviously. You do not want Flipkart to go down even for a minute. So anything happens, we want Flipkart or Amazon to be up. So it needs extremely fast failover. What is the user load? You have too many users. So the transactional part of the application is going to have a hell lot of users. The analytical team may be very small, but because of the transactional team, because of the customers, there are going to be too many parallel concurrent users. Now, time to decide the database. Earlier I said it's transactional, think of RDS or RDS Aurora. If it's analytical, I said think of Redshift. Now it is both. You want to process huge amount of data, you want to fire a lot of complex queries for analysis, you also want to do transactions, you also want quick failover, you also want extremely high latency needs. Neither Redshift nor RDS can satisfy all of this. But this is a very practical scenario we face in multiple production applications. So what do? We smartly use a combination of RDS plus Redshift. The RDS takes care of everyday transactions and Redshift helps with analysis. So how is it done? All the transaction, all your processing, all your customers' feedback and everything is stored live into an RDS. It's a transactional system. It is extremely fast. But maybe once in an hour or once in 4 hours or once in a day, you copy the data behind scenes from RDS to Redshift and ask your analytics team, hey, you connect to Redshift and do all your analysis. So you keep the past data, 6 months, 1 year worth of data into Redshift. You copy them maybe once an hour and let your analytics team do analysis. On top of that, your transaction system continues to work extremely fast with the RDS system. Again, do you want to use RDS or RDS Aurora? Depends on the type of use case. For Flipkart Big Billion Day, it is something very similar to IRCTC. So I might recommend RDS Aurora plus Redshift combination. Now we have learned different examples of Simple RDS, Aurora, Redshift, a combination of them. There is one more peculiar scenario what we are going to look at. Let's assume you want to do log analysis. You want to look at a lot of log data from different applications and different services in your AWS cloud. And you want to analyze this and identify patterns of application failure, patterns of suspicious behavior, and all of that. So you might be doing this log analysis maybe once a day or maybe once a week or once a month. Let's say you have a security team who performs this log analysis every week to identify suspicious patterns. Now, is it an analytical system or a transactional system? Pure analytical system. They are going to read and fire a lot of complex queries and identify patterns out of it. Does it have extremely high latency? No. It's an offline activity, can sustain with low latency. Do you need rapid scaling? Medium, because there is huge amount of data. We may need higher computational power. Huge amount of data? Yes. 6 months worth of data or maybe even 1 week worth of data of logs can be extremely huge, can run into petabytes of scale. Do you want extremely fast failover? No. Do you have extremely high user load? No, because it's a typical analytical system. Now, you tell me what is the database you will use. It's an analytical system, so you will say it's very simple. I will use Redshift. But think about this. This log analysis is being done once a week. Probably apart from this team, no other team is going to look at logs of past 1 week or anything. The application development team may look at logs when there is failures. Otherwise, no one is looking at this log. And this security team wants to look at this log once a week. And this log can be petabytes of data, petabytes, if not terabytes. Now, storing all of this data in Redshift and doing analysis once a week, it is going to lead to extremely high storage cost for very less value. You will read this data once a week, but you are going to store petabytes of data for that purpose. So what will you do? You will use Redshift, but you will use a tweaked version of it called Redshift Spectrum. So what is Redshift Spectrum? So in Redshift Spectrum, you will use the computational power of Redshift, but the data will not be stored in Redshift. Rather, it will be stored in AWS S3. So Redshift will connect to S3, pull the data and do the processing. But it will use its own computational power. It will use its own abilities of doing parallel computational processing. So this is called Redshift Spectrum. So whenever you have extremely huge amount of data and you want to perform one-off analysis, you will connect your Redshift to your data source, which is S3, and then you will use something called Redshift Spectrum. So that is all I had today. We looked at 5 different practical scenarios, evaluated them against 6 key criteria, and learned how we can choose the best AWS relational database. I hope you liked this content. I hope you got something to learn, and do consider subscribing to our channel if you have not already done. Catch you in the next video. Thank you and bye-bye.